What if everything you've ever seen, every planet, every galaxy, every law of physics, wasn't floating in the great openness of space, but instead trapped inside something far more ominous, not orbiting around a black hole, not being pulled toward one, but sealed within it? This might sound like the opening line of a sci-fi thriller, a far-fetched what if from someone with too much imagination, but it's not. This is a real theory being considered by real physicists, one that doesn't just rest on speculation, but on math, on Einstein's equations, on hard data. It starts with a simple, disturbing question. Why does our universe look so much like the inside of a black hole? Why does it have a boundary we can't cross? A mass and density that match perfectly with the equations used to describe a black hole? Why does it behave, mathematically, as if it were contained inside something? The more physicists study this, the less it sounds like a wild idea, and the more it sounds like a missed truth staring us in the face. Because black holes aren't just voids, they're regions where space and time collapse into something new, something different. And some scientists now believe that our Big Bang wasn't the beginning of everything. It was the inside of something else, something that died and gave birth to us. So what if we aren't drifting through empty space at all? What if we're living inside the graveyard of another universe? And what if the darkness surrounding us isn't empty, but pregnant? A black hole isn't a thing, it's a consequence. It's what happens when matter becomes so dense, so compact, that it folds space and time around itself. The result isn't just heavy, it's catastrophic. Gravity becomes overwhelming, not metaphorically, literally. Not even light, the fastest thing in the universe, can escape. At the center of every black hole lies the singularity, a point where density becomes infinite, and the curvature of space-time shoots off the charts. No one knows what exists at the singularity, because all our equations fail there. It's like a dividing line between physics and mystery. Surrounding it is the event horizon, an invisible boundary where escape is impossible. If you cross that line, you're not sucked in, you're simply gone. Every path you could take leads deeper inward. Not even information in theory can get out. And time. It behaves differently near a black hole. To someone falling in, things feel relatively normal. But to an outside observer, that person appears to freeze at the edge, moving slower and slower, fading into darkness. It's not an illusion. It's how time actually stretches and distorts. We think of black holes as monstrous space vacuums, but in reality, they're elegant distortions in the fabric of existence. They don't pull like a magnet. They trap like a maze with no exit. Once inside, you're not crushed. You're cut off from the rest of reality. So here's the unsettling thought. If a black hole's interior is a separate, self-contained region of space-time, then why couldn't it feel, from the inside, like a universe? We tend to think of the universe as infinite, an endless sprawl of stars, galaxies and possibilities. But that's not quite true. Our universe has an edge, not a physical wall or a fiery border, but a limit to what we can observe. It's called the cosmic horizon, and it marks the farthest distance light has been able to travel since the beginning of time. The speed of light is fast, but it's not instant, and the universe is only 13.8 billion years old. That means anything farther away than 46 billion light years, factoring in expansion, hasn't had time to send its light to us. We'll never see it, not because it's not there, but because we're causally cut off from it. That's not a theoretical concept, it's a measurable boundary, a hard limit on what's visible, knowable, reachable, and the resemblance to a black hole's event horizon is striking. Inside both the black hole and our observable universe, there's a finite zone from which no information can escape or reach us. Both are defined by light's inability to cross a certain distance. Both mark a one-way barrier, beyond which lies total uncertainty. In black hole physics, that barrier is created by intense gravity. In cosmology, it's created by rapid expansion. But in both cases, the result is the same: a sealed-off region with its own internal logic. So ask yourself, if you were living inside a black hole and you could only see the space within your event horizon, wouldn't it look a lot like our universe? A vast, expanding space, bounded by a limit you can never cross. Speculation is one thing, math is another. So physicists asked a simple question. If you took all the mass in the observable universe and packed it into a single region, how big would that black hole be? The answer: almost exactly the size of the universe we live in. That's not a rough match. It's not kind of close. The mass of the observable universe, when plugged into the Schwarzschild equation, the formula for calculating the radius of a black hole, produces a result that mirrors our universe's cosmic horizon with uncanny precision. In other words, if you didn't know where the numbers came from, you'd assume you were calculating the properties of a massive black hole, not a universe. This isn't a thought experiment from a stoned grad student. It's a real physics exercise done in postgraduate programs. And every time the answer comes back the same. A black hole with the mass of our universe would have a size exactly like our observable cosmos. It shouldn't line up, but it does, which forces a deeper question. If our universe behaves like a black hole, is sized like a black hole, and has a boundary like a black hole, then why do we still insist it's not one? Either this is the biggest coincidence in the history of physics, or it's a clue to something fundamental we've misunderstood from the start. Einstein didn't believe the universe had a beginning. In fact, he fought against the idea of a cosmic origin for years. But ironically, his own equations planted the seeds for one of the most radical possibilities in cosmology. General relativity tells us that mass bends space-time. The more massive something is, the more space and time curve around it. Black holes are the most extreme expression of that idea, a total collapse of geometry into a singular point. But the equations don't just predict collapse, they predict continuation. If you follow the mathematics through the singularity, especially in extended solutions like the Kruskal-Shakeres coordinates, the black hole doesn't end. It tunnels, it transitions, it opens up into something new, a region of space-time disconnected from the one it came from. In simple terms, what goes into a black hole could come out the other side as an expanding universe. This isn't fantasy. It's baked into the framework of general relativity. And some physicists now believe the Big Bang wasn't a standalone explosion, but a rebound. The beginning of time as we know it, emerging from the end of time in a different universe. Inside the event horizon, space doesn't just collapse, it reinvents itself. So maybe our Big Bang wasn't the moment something came from nothing. Maybe it was the moment something came through. In a universe born from a random explosion, you'd expect chaos, disorder, galaxies forming with no rhyme or reason. Some spinning one way, others the opposite, like cosmic leaves scattered in every direction. But in 2021, astronomers noticed something strange. They surveyed hundreds of spiral galaxies across the sky. These galaxies, like pinwheels of stars, rotate in a specific direction. And when they tallied the results, the numbers weren't random. Roughly 2/3 of the galaxies studied were rotating in the opposite direction of the Milky Way. That shouldn't happen. In a universe governed by isotropy, the idea that space looks the same in every direction, galaxy spins should average out to 50-50. Instead, we're seeing an imbalance, a net rotation, a preferred direction, and that raises a massive red flag. Because to get spin, you need a cause. Angular momentum doesn't just appear, it has to come from somewhere, passed down, conserved, inherited. If the entire universe is rotating, even subtly, then that motion must be a remnant of something larger, something that spun before our universe existed, something that passed its motion on, like a collapsing star spinning faster as it shrinks, or a swirling black hole giving birth to a cosmos that carries its momentum forward. We're not supposed to see patterns at this scale, but we do, and that might mean we're inside something that once spun, and spun us with it. In physics, some things are sacred. Energy, momentum. And perhaps most mysterious of all, angular momentum, the property of rotation. It doesn't vanish, it doesn't degrade, it moves. It's passed from system to system, preserved like a fingerprint stamped onto every new structure that forms. You see it everywhere. Planets spinning on their axes, stars rotating, galaxies swirling in space like cosmic whirlpools. That's not a coincidence, that's a consequence. Now imagine an enormous cloud of gas collapsing to form a star. Even if it starts with the faintest hint of rotation, as it contracts, that rotation speeds up. Just like a figure skater pulling in their arms during a spin, the motion tightens, accelerates, preserves momentum. Now expand that idea to something bigger. A dying star collapses into a black hole. That spin doesn't disappear. It becomes part of the black hole's very nature. And if that black hole gives birth to a new universe, the spin continues, passed down, preserved. In this view, the rotation we observe in galaxies isn't random. It's inherited, not from the Big Bang, but from before it, from the angular momentum of a parent universe collapsing into the singularity that became our own. It's not just poetic, it's perfectly consistent with the laws of conservation. Our universe might be a cosmic echo, a spinning, expanding imprint of something that came before. And every rotation we measure could be a reminder that the past never really disappears, it just changes form. Black holes don't just bend space, they twist time itself. Near the event horizon, time behaves differently depending on your perspective. To someone falling in, time feels normal. But to an outside observer, that person appears to slow down, inching toward the horizon forever. They never quite disappear, they just linger. This isn't just theory, it's a real consequence of Einstein's relativity. Time and space are woven together, and intense gravity stretches both. But what if this strange effect is more than a curiosity? Some physicists speculate that as matter falls into a black hole, its information is preserved, but stretched across time. What we see from the outside is a kind of frozen moment. But from the inside, that moment could stretch into an entire timeline. In other words, while we see a black hole as a static object, from another frame of reference, an entire universe could be playing out inside it. Time dilation makes this idea more than just metaphor. It suggests that black holes don't just contain space, they contain histories. Not our history perhaps, but one just as real. When we stare into the darkness of a black hole, we may not be looking at emptiness. We might be witnessing the slow-motion birth of another universe, a timeline we can't access, a reality we can never visit, but one that's unfolding, fully, richly, just beyond the veil of gravity and time. And if that's true, then every black hole is more than a grave. It's a portal, a womb, a mirror to a cosmos not our own. In the 1970s, Stephen Hawking made a discovery that shook the foundations of theoretical physics. Black holes, contrary to everything we thought, aren't completely black. They emit faint radiation, now known as Hawking radiation, and over unfathomable spans of time, that radiation causes them to evaporate. But this breakthrough introduced a devastating problem. According to quantum mechanics, information can't be destroyed, not ever. It can be scrambled, hidden, rearranged, but it must be conserved. That's a core rule of the universe. But general relativity, Hawking's own framework, says everything that falls into a black hole is lost, erased at the singularity. When the black hole vanishes, so does all the information it consumed. That creates a direct contradiction, one of the deepest and most troubling in all of science. It's called the black hole information paradox. But what if there's a way out? What if the information isn't destroyed? It's transformed. What if the interior of a black hole isn't a terminal grave, but a new beginning? A universe where all that collapsed matter and energy and information reorganizes into something coherent. Our universe, perhaps. In this view, the paradox vanishes. The information isn't lost, it's reborn in a new space-time. the laws of physics are upheld. Both quantum theory and general relativity remain intact, and the Big Bang wasn't an unexplainable event. It was a conservation of information playing out in a different frame. Maybe the most mysterious explosion in history was just another universe keeping the books balanced. If black holes can birth universes, and our universe may be the inside of one, then we have to ask, is this happening again and again? What if we're just one leaf on a vast cosmic tree? This is the idea behind cosmological natural selection, a theory proposed by physicist Lee Smolin. It suggests that universes might not just exist randomly, but reproduce, that black holes don't just end space, they start it. And every time one forms, it creates a new universe with slightly different physical laws. Some universes might die quickly, some might never form stars, but others, like ours, produce galaxies, life, and crucially, more black holes. Those universes create more offspring. They pass on the parameters that made them successful, not through DNA, but through geometry, through physics, through the equations encoded in the structure of space-time itself. In this model, the multiverse isn't a branching tree of pure chance, it's an evolving system, one where universes adapt to create conditions that ensure their own continuation. And black holes? They're the reproductive organs of reality. This doesn't just explain where we came from, it suggests why our universe seems so fine-tuned for complexity, why the fundamental constants of nature sit in such a narrow band between chaos and order. It's not a miracle, it's inheritance, a cosmic Darwinism playing out across an ocean of space-times, where black holes aren't ends, they're bloodlines. Let's take it seriously for a moment. Let's say the universe is inside a black hole, that the Big Bang was the birth of a new space-time inside the collapsed core of a dead star, or maybe a dead universe, that everything we see is confined, inherited, and spinning forward from a collapse we'll never witness. What changes? First, our idea of beginnings is shattered. The Big Bang isn't an origin, it's a transition, a baton passed from one cosmos to another. Second, black holes become more than threats. They become creative. Every time one forms, it might be creating a universe, maybe countless universes, some rich and complex like ours, others dark and brief like cosmic misfires. Third, it explains the fine-tuning of nature, why physical constants are so perfectly balanced, why stars form, why matter clumps, why life can emerge. Maybe our universe isn't the result of a miracle, but the product of generations of trial and error. It also means that what we call nothing is full of potential, that every death of a star, of a system, may be planting the seed for something new. And last, it reframes our role. We're not floating aimlessly in a meaningless void. We're inside a vast recursive structure, one collapse deep, maybe thousands. Everything we know may be happening in the interior of something else. And when we look at the black holes in our own sky, the ones we thought were silent, we may be looking at the next generation of universes waiting to be born. Not just voids, but futures. So what do we do with this? We can't travel beyond our cosmic horizon. We can't peer back through time to confirm if the Big Bang was really a black hole's second act. We may never escape the structure we're inside, if it truly is a structure, but the signs are everywhere, in the math, in the spin, in the shadows cast by collapsed stars. We live in a universe that hides its deepest truth behind veils of gravity and distance, but maybe in the end, it's been showing us all along. Maybe black holes aren't warnings, maybe they're messages, maybe they're the universe whispering, this isn't the end, it's the beginning. We look at black holes as monsters, things to fear, but what if they're the very mechanism that makes new creation possible? What if they're the reason anything exists at all? And what if the next universe, the one to follow this one, is already forming right now in the dark heart of some collapsing giant light years away? We may be trapped behind a cosmic horizon, But inside that boundary, we can think, we can imagine, and maybe that's the whole point, because even if we never escape this universe, we can still understand it. And sometimes, that understanding is enough to make the darkness feel not so empty.